Hello everyone, my name is Omar Natu. I'm a PhD student in the Faculty of Sciences of Tetouan, and I'm happy to present to you my work entitled Fall Prevention Through Cortico-Muscular Activity Monitoring. My work is under the field of home automation for the elderly, which is a big field. And the first question that might come to mind is why fall prevention exactly? Simply because falls are the leading cause of injury, long-term disability, and injury-related mortality for older adults. In fact, 32 to 42% of people aged 70 and above face a falling incident each year, and these numbers are even greater when the person suffers from a neurodegenerative disease such as Huntington's disease, Parkinson's disease, or ALS. Such diseases are usually characterized with involuntary movement. It is an interesting field, and a great deal of research has been conducted to mitigate this problem, mostly on two main topics that are fall detection and fall prevention. After collecting information about the state of the art, we were able to form a clear idea about the problem and also form our own problem statement and an approach to solve it. So, elderly people with neurodegenerative diseases suffer from involuntary movements that can lead to falling. Our approach to the problem should be around two major pivots. The first is fall prediction, real-time synchronous monitoring of brain and muscle signals with EEG and EMG technology gives the possibility to detect an involuntary movement prior to its occurrence with a time window of 100 milliseconds to 500 milliseconds, depending on the said movement, if it's a tremor, a tick, a spasm. Such detection is possible thanks to the premotor potential, such as buried shaft potential (BP) detected in the motor cortex area before the muscle activation in the band of 2 to 5 hertz. Also, the mu rhythms detected in the band of 7 to 12 hertz, and beta rhythms detected in the band of 13 to 30 hertz. Such detection gives way to corrective feedback. The second pivot is fall prevention. So after detecting the fall movement, a corrective action should take place within 300 milliseconds in order to ensure successful intervention. According to a study on 125 subjects, it was found that a reaction time of 300 milliseconds or lower return a probability under 0.01 of falling. So, as a result, the aim of this research is to develop a system for fall prevention through real-time synchronous monitoring of brain waves with EEG technology and muscle signals with EMG technology for prior detection of involuntary lower limb movement related to neurodegenerative diseases. The system should be able to generate a corrective biofeedback reaction in the time window between the detection of the involuntary movement and before its actual occurrence, ideally within 300 milliseconds. The system should be able to differentiate between the types of those involuntary movements and generate, as a result, adequate feedback. To ensure the comfort of the user, the system should be wearable and non-invasive. So this is the actual state of our work, our research, and future work should tackle the possibility of artificially simulating the premotor potentials said before, BP, mu, and beta rhythms that precede the involuntary movement. This will give an in-depth look at the phenomenon and will lead to a better understanding of it. Simulation possibilities for deep neural networks should be looked into as well in order to benefit from the technology's unmatched classification power. Also, further research should be conducted in terms of the types of involuntary movements related to these diseases. Such classification will surely give an idea about assigning biofeedback stimulation proper to each foul movement. To conclude, this simulation of the system's algorithm will sure give an in-depth view on the system's strengths and weaknesses before proceeding to realization. It is hoped that such work will help reduce the harmful consequences of falling of older adults while providing them with autonomy and security. It was a pleasure presenting you this work. Thank you for your attention and for your interest in it, and I will be happy to answer your questions.